webinar, The Future of Service Assurance for Telecommunications Operators, sponsored by GreySkies. Before we begin, I want to cover a few housekeeping items. On the left-hand side of your screen is the Q&A box. If you have any questions during the webcast, you can type your question into the Q&A box and submit them to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask for your feedback. A survey is already open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading's Research Director, Cloud and Security, Jim Hodges.
Thanks, operator, and welcome everybody to today's session. So today's webinar is entitled The Future of Service Assurance for Telecommunications Operators. And as the title suggests, we're going to be talking about service assurance because over the last 18-24 months, service assurance has become a really focal point for service providers, telecommunications operators, as they roll out new services, as they look at new technologies, such as cloud and automation. So we're going to be focusing on that from this perspective today. So it's going to be a really interesting session. So today's session is sponsored by GreySkies, and what we're going to be doing is we're going to be focusing on really how service assurance is kind of evolving, and more importantly, what the future of service assurance really looks like for service providers. When you take all these technologies that are really shaping how service assurance is going to evolve. So we're going to first start by considering the factors that are really kind of driving or fueling this service assurance evolution and what this means for even the development of service assurance platforms. And then from a service assurance platform context, we're going to hear from GreySkies on their service assurance platform design strategies as well. So we'll be doing that. We're also going to be including a demo in today's session, and then we'll wrap up and we'll take your questions. So let me first briefly introduce today's speaker. So joining us, as I said, GreySkies is sponsoring today's session. Joining us today and presenting from GreySkies is Ahmed Mokthar, who is the founder and CEO of GreySkies. So welcome, Ahmed. Looking forward to your presentation.
Thank you, Jim, for the introduction, and hello, everyone tuning in. It's a pleasure to be here with you today.
Before we get started, before we jump into some of the evolution stuff and service assurance evolution, maybe you can tell us a little more about GreySkies.
Sure. Let me give you a brief overview of GreySkies. At GreySkies, we offer cloud-native service assurance software solutions to the telecom market and to the large enterprise market as well. We're headquartered in Seattle, Washington, and we've been offering our solutions to the market since 2016. Our solutions are currently up and running, operating at scale at a number of leading mobile and fixed network operators around the world.
Okay, perfect. Thanks, Ahmed. Okay, so let me just kind of jump into it. As I said, I really want to talk about the evolution of service assurance. When I look at service assurance, and I've been covering it for three plus years, 3 years ago, I really noticed that as we moved from NFV moving into the cloud, that service assurance and orchestration were really important topics for service providers because they were dealing with traditional systems that were never designed to be really running in the cloud. So if you think about service assurance, some of the factors that are really driving this evolution, just start off first with cloud native. Obviously, with cloud native, we have 5G technologies. It's the first 5G core that's cloud native. We also have microservices, software disaggregation, API exposure. Some of these have been around for some time. Even with NFV, we were starting to look at microservices and software disaggregation, but we're really moving that to a much greater level now. And with that, it comes with some really new requirements to really support service assurance, even in terms of how you design service assurance. Fundamentally, you have to be able to design cloud-native service assurance platforms to support these cloud-native services. And then advanced use cases, I think it's fair to say that there's a completely new portfolio of advanced use cases that are coming out. Some are driven by 5G, things like slice-based services, private and multi-cloud. So there's a lot that's really happening from an advanced use case. And I've got two of them here, as I said, private and multi-cloud and slice-based networking. But I think you really have to think about other things in terms of, when we look at use cases, we're thinking about how we're going to integrate mobile and fixed networks. We're thinking about how that's going to have really an impact on how we develop use cases. And I think that's really where we are right now in terms of the 5G monetization and cloud cycle. We're really kind of finalizing advanced use cases, and now we're moving as an industry to monetize them. We also have to think about operations and security operations centers, really focusing on, in the past, we had kind of a focus on manual versus automated policy. We really now need to think about end-to-end security enforcement. There's really a lot of moving parts to this as well, especially because these operations have to support these advanced use cases and also be able to support operations for monitoring and policy in a cloud native. And that could be, as I said, software disaggregation at the edge. So there's a lot more considerations from an operations and security perspective than ever before. And that's not changing. We're just really now entering sort of the development phase of that. And then the other part of this is QoE, customer care. This is a really important part of this. Obviously, as we think about services, we need to think about what the customer's experience is going to be looking like. And obviously, with cloud services and 5G services, we're really focusing on ultra low latency budget services because a lot of them are video streaming. So there's some challenges here about maintaining and driving QoE and being able to support these really tight latency budgets. And then also customer seamless service experience. So at the end of the day, the customer doesn't really care where the service is being executed. All they really care about is that they have the right type of service experience. So, from a QoE, customer care operations, and even from an advanced use case, this is, I think, where, advanced learning and AI is really becoming part of this, because obviously AI can be used for automated policy. AI can also be used to support analyzing service experience. It can also be used for driving new use cases. So there's a lot of, I think that's a real reason that service assurance is really focusing on exploring how automation can be used for things like proactive quality management and really contributing to overall customer satisfaction. And as I said, we're just entering that domain now, and there's going to be a lot of work going on. But as we're going to be focusing on today, we want to talk about what the service assurance platform's requirements are. So if we think about this, I've taken those same kind of variables, advanced use cases, cloud native operations, and SOC and QoE. And I'm kind of thinking about what does it mean from really a service assurance platform design perspective. So, as I said, at a high level, all of those things I just talked about, really service assurance platforms really need to be able to support these foundational capabilities to provide the best experience possible. They need to be able to manage data. They need to be able to support customer experience related and crowdsourced data. They need to be able to provide a really strong view of what the customer satisfaction metrics are like, both in internal and running in the cloud. So essentially what we're really talking about is being able to support services on a per subscriber QoE level. And that drives a lot of stuff in terms of analytics. So at a high level, I just wanted to kind of point out, if you think about crowdsourced data, that's really important to understand how customers are really experiencing services on, externally. And those, things like advanced use cases and cloud native, those are all things that service assurance platforms need to be able to integrate to support this crowdsourced data, because it's going to be in real time. It's going to have an impact on branding, on service adoption, all these types of things as well. And then active probing, obviously probes have been in the networks for years, and they are really providing an experience, or a view of the experience and data movement within the industry, within the network. But we have to think about how, now that some of these services will be cloud native, and then also have to think about how support active probing and software defined, fully programmable services, how that's also going to impact the operations and SOC as well. And the same thing, end-to-end service alarms and KPIs. Obviously, KPIs will be an important part of this. KPIs have always been an important part of service providers' view of how they manage their services and meet service requirements for their customers. But again, on an operations perspective, tighter latency budgets, those KPIs are tighter, and you have to look at it from an end-to-end perspective as well. And then obviously advanced use cases, which I said are really evolving into a number of different ways. Network elements and KPIs, thinking about alarms and configurations, those are obviously have a direct impact on operations in the SOC, and also the cloud native services will have an impact as well. And then the other two areas, customer care, I'll start with first. Obviously, customer care is key to all this, being able to provide a positive QoE for customers. But when customers do need customer care and support, they need to be able to use their service assurance platforms to be able to provide that, and also support these advanced use cases as well. And I'll end up with customer experience data per subscriber analytics. This is, again, kind of ties it all together, because at the end of the day, the customer needs to be able to have an excellent, strong level of service for all their services. And the service providers need to be able to understand which services are meeting per subscriber analytics, because really at the end of the day, they want to be able to provide this kind of customized services on a per subscriber level, from all types of data, from crowdsourced to network data to operations to SOC. So again, there's a lot of moving parts from this, from a service assurance platform requirement. This is driving a lot of the evolution of service assurance platform. That's what we're going to talk about for the remainder of our session today. So with that, I'm going to turn the presentation over to Ahmed, and you're going to do a kind of a deep dive into these topics in more detail, and give us a little bit of information on how you developed GreySkies, developed a platform that'll support it. So I'll push out your first slide. Please go ahead, Ahmed.
Thank you, Jim, for this great overview. And following on to this theme of the foundational capabilities that you just articulated a few minutes ago, the way we actually designed and built GreySkies allows us to realize this vision. This has been informed really by 25 years of working within and with telecom operators. And when it comes to service assurance, it always comes back to these set of questions. What's going on in our network, and how are the services performing, and what are the customers experiencing using our services, and how's our network actually performing? Does it stack against what we're hearing? And are customers complaining? Do we see customer complaints, understand where these are? And then more recently, obviously, what's the world saying about us? And so we really set about building a platform that comprehensively and holistically addresses these questions. So we start with the platform. You ask first question, how's the network doing, or what's going on in your network? And so from a network element KPI, alarms, configuration, logs, we're going to ingest all of this information at the network element level. But obviously, that's important for network operation centers and the like, and it's foundational, but it's not enough. We want to enrich that with service level KPIs of critical revenue generating services that service providers have, 5G, mobile internet, VAS services, etc. We need to understand and see how these services are performing end to end. Associated with that are their own alarms, KPIs, and metrics. But we can do better than that. And by overlaying customer experience data per subscriber analytics that we can ingest through massive CDRs, EDRs, transaction logs, and so on, and tying it with the service and network, really illuminates how what the customer is experiencing, and allows us to quickly localize any issues, any performance issues that take place. When we ask about how is the network performing, one thing that we can do is through control tests. Through control tests from specific strategic points in your network, we can test for latency, jitter, video download times, a variety of whatever measures that indicate and help us understand what's going on in the network. Particularly, this is very helpful when it comes to localizing where the issues is a last mile issue, or is it related to the core? And so layering that information on top of the first three pillars that we have, it adds a significant dimension and texture to the service assurance experience. Customer care logs we can integrate with an operator's CRM to really tap into the tickets that are being opened in response to customer complaints, and correlate that with the rest of this view. This is all about getting this complete 360-degree view of service assurance. And then laying on top of that the crowdsourced data. There's great services like Down Detector and what have you that will obviously measure the external the performance of service provider networks externally. and aggregate social media feeds about what people are saying about the network performance, we want to know what people are saying as well. And so putting it all together and provides this 360-degree view. Now, not all operators want to have that entire stack, and different operators might have network element service and customer experience. Other may be focused on network customer care logs and customer experience. And so the platform is modular enough to allow us to ingest that type of information and tailor it to the operator's needs. So fundamentally, once we've collected all this information, now we can do the fun things with it, of course. Dashboarding and reporting, alerting on it, leveraging automation and self-healing use cases with all this information, and then also leveraging analytics, correlation, and machine learning with this data set. Now, traditional service assurance is based on the FCAPS model, which is a very useful framework to define these critical functions. And the industry has built many dedicated solutions to each and every one of those modules. But particularly when it comes to fault, configuration, and performance, there's just a lot of, obviously, solutions addressing these aspects of service assurance. And with the complex nature of service provider networks, whether it being mobile network, fixed, telco, cloud, enterprise, and you have another dimension in terms of the function, whether it's fault, configuration, and performance, you end up really with many point solutions. And these solutions don't always integrate and talk to each other. And so inevitably results into poor service management performance, lack of end-to-end visibility, and we're not going to be able to really easily correlate between what the customer experience is and pinpointing where the issue might be, which network element, which service element is impacting. And obviously with these point solutions, there is an impact on your budgets. From an operations budget, you have maintenance, support, training, all sorts of issues surrounding that as well. So it's inefficient certainly from a budgeting perspective. Now, we believe that service assurance, the future of service assurance, is undergoing a paradigm shift. And we like to think of ourselves as leading that effort and being certainly part of it, if not leading it. And so there's a mindset shift that has to take place as well. And that relates to the fact that when we're collecting data from the network, this collection, we're not necessarily going to be looking at fault data, performance data, log. We want to ingest everything: metrics, logs, configuration, performance, and all that to us really is information. And we need to organize this data, tag it properly, and leverage it in the right way, and leverage new technologies like machine learning, like advanced analytics and automation to really extract value out of this data. So whether it is data coming from, to Jim's point earlier, in terms of integrating services coming from traversing multiple networks and technologies within a service provider, whether it's coming from the mobile network, the fixed, the enterprise, the telco cloud, customer experience metrics, business metrics, revenue, charging. We really need to ingest. We want to ingest all this data, organize it, and this will enable us to then provide this end-to-end visibility, this correlation between customer experience, network, and service. And obviously, as part of that, this will help with the consolidation of legacy tools from an OpEx perspective. Excuse me for a second here. Next, I'd like to take a couple of minutes to talk about some of the features and capabilities of the platform that really enable this vision that we're talking about. So first is the universal network coverage. And this is our promise to our customers, is that we will collect from any network element, any vendor, any domain, physical or virtual. This is our promise to our customers. We've built a system for that because we understand that this mindset shift that we just talked about in terms of collecting information, we need any system with a digital interface we'll interface with and we'll collect this data from. Second, the massive CDR ingestion. We had to design the platform specifically to be able to ingest terabytes of data every day in terms of network transaction, billing and charging, customer experience data. So this is another critical component, and it required some serious technology development to be able to scale the system for this type of data. Obviously, dashboard reports, real-time dashboards, very simple to stand up, takes minutes to stand up a dashboard. You can customize it the way you want. It's all drag and drop. You design and schedule your own reports. You can send them to the stakeholders that you wish. And you can even schedule the generation of these reports upon any incident that happens in the network. So that's really a targeted, focused report at the time of the incident that reduces the time to resolve this issue. Now, obviously, data is the most valuable commodity moving forward. And so once I've collected all this data, really leveraging it through analytics is so important. So whether it's on-the-fly transformation of data that's coming in, real-time analytics, offline analytics, scalable performance alerts, leveraging real-time anomaly detection, this is really where you bring this data alive, and collecting it is not enough. Leveraging it is the important. And continuing with that theme, we have a very flexible, fully programmable automation platform that really can be applied to any part of your network. Again, mobile, fixed, enterprise, and we have use cases in the field currently running in all these different domains. Third-party integrations is another really strategic and critical component of the solution, and it's not only because you want to be integrating with inventory systems and big data warehouse and what have you for northbound interface and pushing all this data out, but it relates really to the ability of this system to stay current to actually what is actually running in your network, constantly automatically refresh that, and more importantly, it allows us to enrich data that is coming in so that we can tie everything together. So this third-party integration capability and the understanding of how to do that the right way, whether it's for topology discovery or network element discovery or metadata enrichment, is really critical to this view of the world. Synthetic testing, active probing is the idea. Again, we talked about it, fully programmable. You can design your own tests, use out-of-the-box tests, TWAMP, URL endpoints, ping testing, all these different components, whether it's on 2 points of your network, within your network, 2 strategic points, or even if it is 1 point in your network and an external service that you want to test against. And then finally, multi-tenancy. And multi-tenancy, obviously, service providers are large organizations. There's many internal stakeholders, and there's multiple departments, each responsible for their own network elements. And so through role-based access control, LDAP integrations, different departments can only take a look at their own network elements. And so an IP core team might be looking at routers, switches, firewalls. The mobile access teams looking at eNode Bs and GNode Bs and the various radio nodes, and so on and so forth. But not only that, there's also the ability to leverage the multi-tenancy. The platform is MSP ready, managed service provider ready. So you can offer external views or views to external stakeholders like your enterprise customers, or even if you're launching MVNO service to other operators, you can give them views to ensure SLA, that you're meeting the SLAs from a service perspective. You can provide views to these MVNOs. Companies like neutral host providers, third-party operators, these all that have multiple stakeholders, the platform is really sort of MSP ready from that perspective.
Ahmed, maybe before you move on to your next slide, let's go back to the previous slide. I just wanted to ask you there. I mean, obviously, when you started developing this platform, there was a kind of a framework in terms of what was required from a CDR, so cloud detection, which stands for cloud detection response, and EDRs, which is endpoint detection response. But a lot of the CDR and EDR requirements have been pretty fluid over the last 3 or 4 years. So I'm just wondering, how, and when you developed the solution, how have you been able to sort of keep up with all these sort of multiple domains and requirements that have been sort of kind of evolving in real time?
That's a great question, Jim. And it actually, as it happened, just leads into this next slide that I wanted to talk about. And I'll get to that question in just 1 minute. I wanted to start with the important to mention that this is not just about software and tools. This is about really partnering with an operator and a supplier that have a deep expertise in telecom network planning, engineering, and operations. This allows, you need a partner that understands your challenges and that is capable of helping you solve the challenges. So, and a prime example of that is relates to data collection process. When we're collecting massive amounts of data, and if you just essentially dump it into a data warehouse, it's not helpful. And in fact, it could be a hindrance. And that's why you hear all these stories about service providers that have made significant investments in data lakes and data warehouses, and they're not really seeing the return. And because the data is there and they just can't make sense of it. And so really understanding, having the tools, of course, having a great platform is important, but understanding how to tie everything together through consistent and standardized data enrichment is critical. Going back to your question, Jim, in that regard, we have built a platform. We understand that the requirements from a data collection perspective are very fluid. There's different domains, there's different types of logs and records, and the formats are changing. And so we have really built the platform in such a way that we've pushed all the configuration and customization to be able to build these adaptive collectors to the edge of to the edge. And by the edge, we mean to the implementation teams working with our customers and our partners, as opposed to R&D development. And so we've really taken what used to be termed as R&D jobs with long lead cycles for development and deployment, and we've pushed them to the edge, to the implementation crew working with the customer who knows what they want, and we're able to then to realize faster time to deployment, and we can tailor it to meet the operator's needs. So pushing that, we can configure our adapters to the different formats of these CDRs and EDRs. We can introduce new vendors into our collection, all done through by pushing that to the edge. And that's really that's why we think about it as not just a tool out of the box that you use, it's a platform that enables you to really embrace the concept of unified or universal anywhere. And it ties in with the universal network coverage, universal service coverage, and that we're promising our customers will be able to cover. So another point is that we're really technology agnostic. We have advanced capabilities. We have the machine learning and the automation, but really we look at the problems. We're hyper-focused on solving and delivering value to our customers. And so whether it is even using simple thresholds or machine learning, automation, or dynamically generated insights, we're just focused on addressing and solving problems. So we approach our engagement with customers with what are your challenges, what's the best way to solve it? And then technology is just a tool set that we're going to leverage from that perspective. Now, just to give you a sense of the domains and vendors that we've integrated with, and this is by no means an exhaustive list. We've integrated with obviously every aspect of a service provider network, all the way from mobile RAN, mobile core, IP core, enterprise, fixed access, various OSS, BSS system integrations, telco cloud, and you'll see that part in the demo as well, and mobile backhaul. And we can go on, and this is a sample of the different suppliers that we've integrated with. And for us, it doesn't, as long as that platform has a digital interface, we will be collecting data from it as well. Now, we also understand that different customers will have different deployment model requirements. And how do we deploy the software? So we offer a number of options when it comes to that, starting with the public cloud SaaS offering, where it's a no-hassle option, no need to worry about hardware, software, no worry about updates and maintenance. That's all on us, and easy for scalability. As your network grows, the service assurance capabilities grow with it. If a customer wants a little bit more consistent performance, a little bit more isolation, and from a security standpoint in the back end, we have the option of, and still want to be cloud-based, we can still do a cloud-based dedicated instance, where this is kind of the best of both worlds. It's a hybrid, it's in the cloud, and it is certainly providing this additional security and consistent performance option. And then finally, there's the on-premises deployment, whether it's virtualized or containerized. We use your private cloud. You have complete control over the deployment, highly customizable, and obviously this is suitable for if the operator has sort of more data sovereignty requirements and things like that. And we see a lot of that from that perspective.
Ahmed, just very quickly, sort of which deployment, I know it's kind of put you on the spot here, but is there some deployment model that maybe has greater traction? I mean, obviously, cloud-based important. I mean, these are all things that I sort of talked about in my introduction that are driving, and they're all powerful trends in their own right. Public cloud with SaaS because of the cloud developers' services. Is there one maybe these development that has most traction right now?
Well, with large service providers, we're still seeing, certainly there's a big push for going to the cloud. We're seeing that. We're seeing a lot of discussion and talking about that. But when it comes still, because of the subscriber analytics, customer experience, customer identities that we have, a lot of it still, and data sovereignty, there's a lot of, on the ground, we're still, a majority of the deployments relate to on-prem deployments. When you start talking about the smaller tier 3, tier 4 service providers, you start seeing the desire, and different OEMs, the desire to go to cloud. And so certainly the cloud is trending upwards. We're seeing more and more migration there, but there's still security concerns and issues related to customer identities, especially that's driving, keeping the on-premises deployment alive and well for now.
Okay, and maybe just a very quick related question. You know, obviously in all of three of these deployment models, AI and machine learning plays a role in some point. And are your customers sort of asking you kind of for the same type of common principles for how you incorporate AI and machine learning into your design, or is that kind of driving your evolution as well? Because maybe one public cloud model has different AI ML requirements than an on-prem.
Well, let me jump to it right away. Then let me get to that slide here. And yeah, so from a our philosophy from a machine learning architecture, the GreySkies platform offers two sort of distinct views, even though there's a lot of arguments about fusing them in a way. But from our perspective, we have an online machine learning platform and an offline machine learning platform. And the online one really operates on data at ingestions in real time, providing real-time anomaly detections on thousands and thousands of data streams. And it's integrated within dashboards and reports, and with a great roadmap on it. And we'll discuss that very quickly in a little bit. The other side, our view of it is that having an offline platform is very suitable for compute-heavy jobs, intensive jobs that are maybe run once a day or once a week. They're ad hoc. You want to provide a sandbox for the data science team within operators and our data science team to work together with them to prototype, tweak the pipelines, the ML pipelines, and leverage that data. So from a philosophy perspective, we're seeing that there's two tracks in a way, an online track and an offline track, and this is how we're deploying the technology right now, with a lot of roadmap coming behind that. And to follow on that, you know, the bigger picture is, again, relates to ingesting everything: logs, telemetry, transactions, business KPIs, network KPIs, and service KPIs. Ingest all of that, and that is information, and then leverage more advanced, especially in the offline world, the capabilities of and enabling model selection, model training, runtime prediction for these advanced models like recurrent neural networks or gated recurrent units, long short-term memory, graph attention network. There's all sorts of, we have our eye on that direction, because this is where things are going. But again, we have to, there's a lot of hype around all of that information and all that technology, but you have to, it's not about the buzzwords, it's about really understanding what is the right model to use to solve that problem. And this is sort of what we're hyper-focused on. So if we go back to the online platform, and this really is about you know, in many cases, a fixed threshold when you're alerting on is maybe the right approach, but that's not always the case. There's patterns, there's complexity, especially when it comes to going from to perform the correlation, going from univariate to multivariate, and this is what machine learning does really well from an anomaly detection perspective. So the platform is able to ingest these thousands and tens of thousands of these data streams, and you're able to configure all your thresholds and set the sensitivities so that and set different levels of alerts as it relates to the severity of that anomaly, and integrate that within your platform to drive automation, to drive self-healing. And so one really important point to point out, and we've heard this from many of our customers, is that we apply GreySkies because we are doing all the collections. We are near the collection data as soon as it comes, and time to detecting an anomaly is important. And so the ability that we are near the source from a collection perspective gives us really a strategic advantage when it comes to something like real-time anomaly detection, versus having to deal with any additional delays as it relates to applying these algorithms after ingestion and once it is into the data warehouse, and then there's delays associated and inconsistencies associated with that process, and that provides spotty coverage. And so the fact that many discussions with operators go back to, you're near this, near the data collection, we want to be able to do the anomaly detection as soon as the data is coming in. And so this is something that we really, we feel is a very strong advantage for us from that perspective. If we go to the machine learning, the offline analytics, we have our platform. That platform can collect data from the data warehouse. In this case, the time sensitivity is not as important because these are heavy jobs that run perhaps once a day or every 6 hours or every week. So we can integrate with the data warehouse. Of course, we have access to the back end of the GreySkies platform, and you can define your playbooks however you want, and you can run these playbooks, and we call them playbooks after you've designed your ML pipeline and you've designed your tweaked your algorithms to whatever perform the task that you need, and you can run these on demand or in a scheduled manner or event driven. When something happens and you want to run this complex analysis, you can spin it off and run it from the ML platform, and then get back the results within the platform to visualize it and report on it. Keeping with the theme of leveraging this data and what we can do with it is automation. And automation is such an important concept moving forward. Operators in general are obviously coming under severe pressure from a budgeting perspective. And so automation is a key strategy for them. They need to be able to do more with less. And they need to be able to free their staff to pay attention to the more important things and take off of their plates the more redundant recurring actions that take place in the network. And so from our side, we really, since we're collecting all this performance configuration and log data, we blend all this together so that we can perform the requisite analytics and then recommend the remediation action and push that action back to into the network. We have a very flexible and programmable automation framework that you can build your own. You can essentially drag and drop, apply it to multiple devices, run it on demand, run it scheduled, or run it upon an event trigger. So, for example, leveraging automation for doing a self-healing use case. This is a simple example of how all of this ties together. We're collecting all this data. We're going to be able to detect a KPI deterioration. We call this some event assertion. Whether that happens through machine anomaly detection, whether that happens through a threshold, somehow there's an event that has been triggered and we're going to detect that. Once that condition is asserted, we kick off that automation workflow. In this case, for a typical self-healing workflow for us is we open a ticket in the trouble ticketing system of the operator. We need to make sure that before we push this configuration change that will remedy the situation, we need to make sure that the network is in a state that is ready to accept that. And so we do a pre-action validation. If it succeeds, we move on. If it doesn't, we terminate and let the operator know, certainly in this case. If we've passed the pre-action validation, we go into before actually you do not want automation to run amok within your network. And so we believe in a capability called Analysis in the Loop, which allows us to send an email to the operator, the ops team, basically, to look at the configuration, look at the data, and make sure that, yes, I want to proceed with that self-healing action. That makes sense. The ops team will approve that, and once approved, we push the configuration change. If that change is successful, we'll let you know, we'll close the ticket, and we'll send an email notification. And if it failed, we're going to have to roll that back because maybe it's a two-sided action and we succeeded on one side, but the configuration did not take on the other. We have to roll it back to bring back the network to a coherent state. And we have done this type of workflow in multiple domains within network operators. We've done it in the radio access network with active cell restarts. We've done it in the mobile core with the VIMS model. We've done it in IP core. We've done it in fixed access domain. So really the platform is very broad in that sense and can apply these use cases to any of these domains. And it's not only, by the way, applying self-healing into the network. You can automate things like automated order provisioning from if you want to expand capacity in a certain, once capacity reaches a certain limit from a capacity planning. There's a lot of details that we can talk about in this regard. But coming back to the automation remediation work use case, a very salient point that's important to point out is that service provider networks are, by definition, they're redundant. There's many protection measures in place, things like 1+1 protection, 1+N protection, and they're really resilient against hard failures. A node fails, a link fails, the network typically recovers and service is not affected, and it's built in. The telco industry did a great job with that. Where our system really shines is in this concept what we call the soft failures, where a network element, a link or a node or a service element, really doesn't just fail, it just deteriorates, it degrades. And so an example of that is a link that has errors on it, or a Ceph storage disk, an OSD that the commit latency on it is high. These types of degradations, the network element is not taken out of the service, so the network is not able to cope with it, and the service is, the higher level service is impacted. The customer experience may be impacted in that case, whether it's higher latency, if there's errors on the links, or the VNF that's riding on top of that, depending on that OSD, will be impacted in that case. And so this is really where our ability to detect this degradation, and then all we do, the surest way and the quickest way to minimize impact on the customer and minimize any disruption, is to go in and essentially take that element out of service and let the network exploit the resiliency and redundancy that's available within the design of the network, and then open a ticket, send it to the operations team to look at it in detail, while we have really kept the customer experience front and center for us from that perspective. Without further ado, I want to kind of start talking about give you the demo cases, a video, a 9-minute video that walks you through some of these concepts. We're going to demo 4 cases for you, each about 2 to 3 minutes. We hope it gets your full attention, and we think this is going to speak to your, as telco operators, to your challenges. First, a use case that relates to correlating subscriber metrics with service and network KPIs and leveraging machine learning from an anomaly detection perspective. A second is really getting that surround view, that subscriber, service, network, and business view, and tying it all together. And then the third case is, and this is a very hot topic these days with operators, obviously with 5G being energy intensive from a consumption perspective and data centers growing. There's a big focus on energy management and optimization, and we feel that, well, there's lots of great solutions that do that. They're focused on the energy management and optimization perspective. We feel that the ability to do this in isolation is not the best approach, but understanding your traffic patterns, your quality of service metrics, and doing joint optimization of energy consumption, taking all these factors into account, is the right approach. And so we're going to talk about a use case related to that. And then finally, we'll talk about, we'll have a short use case about the service assurance for telco cloud infrastructure and highlighting the automation capability.
Okay, great.
Over to you, Jeff.
Thanks, Ahmed. So yeah, we'll run the demo now, and then after the demo, we'll come back and we'll wrap up and take the questions. Okay, thank you. And so Ahmed, if you wish, you can turn your camera off now as well.
Good morning. Today, we're going to show a demo of the GreySkies service assurance platform for telecommunications service providers and large enterprises. We're going to start with the fixed broadband internet service use case, and we'll show how we use machine learning-based real-time anomaly detection to help your operations teams quickly localize the root cause of any service degradation. First, we look at a dashboard of critical service level KPIs for a large region that includes number of subscribers, latency, and packet discards. The dashboard breaks down these metrics by network elements such as provider edge routers and shows traffic trends over time. We can also see other key metrics such as subscriber uplink and downlink throughput, average IP pool utilization per PE, AAA, DNS, and DHCP requests. Next, we navigate to another view showing the details of the IP pool utilization by region, and the breakdown by PE routers, which also act in this case as BNGs. One powerful feature of the GreySkies platform is the highly flexible topology widget, which shows all the network elements that comprise the service, such as OLTs, PEs, the various CDN servers, DNS, AAA, DHCP, and web filters along with their relevant KPIs. We can also track the upstream international service providers' link utilization and drill down to see important KPIs such as link throughput and packet loss. Closer observation shows that there was service degradation on some key metrics, including the AAA access requests and the web filter HTTPS requests. This is where the GreySkies scalable machine learning-based real-time anomaly detection capabilities shine. The platform is capable of processing thousands of data streams and will alert you to any abnormalities in the data. It will also automatically generate a report upon anomaly detection with the relevant metrics for your operations team to quickly remedy the situation. In this case, it enabled the operations team to determine that the AAA service malfunctioned, which forced all subscribers to log out of the network and then automatically re-log in at the same time, which overwhelmed the service and resulted in traffic degradation. One of the unique features of the GreySkies platform is that can associate subscriber quality of experience metrics from the DPI nodes onto the service topology, thereby bringing together subscriber, service, and network perspectives in one pane of glass. In fact, you can drill down on the OLTs to see the top attached subscribers along with the relevant QoE KPIs. As we've navigated through the GreySkies platform today, you've witnessed firsthand how transformative it can be for service providers striving for efficiency and actionable insights. In this demo, we're going to highlight the capabilities of the GreySkies Service Assurance Platform in terms of truly providing a comprehensive, integrated view of network, service, subscriber, and business metrics all together. While understanding customer experience in the aggregate in 4G and 5G networks is very important, it is very insightful to be able to examine experience on a per-customer basis. Having ingested various CDRs and transaction records, the GreySkies platform allows you to understand the behavior of a specific subscriber by visualizing their application usage, data volume consumption, and quality of experience, using the multi-layer map widget and various drill-down capabilities. Furthermore, we can use the playback feature of the platform to look at a time-lapse sequence that reveals the customer experience, what application they used, and where they used it during different parts of their journey. This is particularly insightful when a customer complaint is received, and the quality team wishes to localize the issue to a specific cell, site, or application. Having correlated the charging records with the subscriber transactions, the GreySkies platform enables you to tie key business metrics such as revenue with network and service elements. This allows you to determine the revenue generated from a given site or location, which can be broken down by customer profiles, subscription packages, and applications. Now we bring it all together by considering a scenario where a number of complaints were received from customers not able to access their mobile data and voice services. The GreySkies platform had localized the issue to a specific site, where in a single view, we are able to view the customer experience metrics at that site, along with the generated revenue, which clearly shows customer impact and revenue loss. In the same view, we can observe RAN KPIs whereby cell availability, radio access bearer setup success rate, and PRB utilization had dropped to 0. Narrowing our timeline view to precisely examine the incident interval and taking advantage of the capability to overlay network and service alarms on the same chart, we can see that a number of alarms were generated during the incident. Further drill down reveals several alarms indicating the link between the MME and eNode B is down, which identified the root cause of the incident. Next, we look at an important issue facing many operators, and that is energy management and optimization. Network operators face increasing pressure to reduce energy consumption and improve energy efficiency due to the growing demand for services and rapid expansion of network infrastructure. Conventional wisdom was that managing radio network energy efficiency is enough, but that is not entirely the case. Data centers are becoming major consumers of energy, which will continue to grow with the advent of generative and analytical AI workloads. There are many initiatives that must be put in place to address this issue. However, an intelligent multi-layer energy-aware service assurance solution, such as the GreySkies platform, can be a key enabler for operators in their journey towards better energy efficiency and lower total energy consumption. As an example, this is a view of an operator's radio network energy consumption, which we can track over time and visualize on a heat map that identifies hot spots. We can then look at the top energy-consuming sites by technology and classify them on maps for subsequent optimization activities. The power of the GreySkies platform is highlighted by bringing together energy consumption, traffic load, and quality of service together to make optimal decisions. Traffic energy efficiency, defined as the traffic carried per unit energy, is such an example. Identifying low-efficiency sites, which are sites that are consuming a lot of energy, but carrying little traffic, then drives optimization plans such as cell resectoring or rerouting traffic. In this demo, we're going to dive into comprehensive service assurance for the telco cloud along with its applications using the GreySkies platform. First off, here is a high-level overview showing the vendors used, device types, and counts with model and OS versions. We then jump to the automatically discovered data center topologies, where you can see data center gateway connections to external PE routers and to spine switches. We can also see a more detailed topology for the data center gateway, spine, leaf, and management switches along with OpenStack controllers and compute nodes as well. The health, status, and utilization metrics for the NFVI hosts including OpenStack controllers, compute nodes, Ceph storage nodes, and SDN controllers are monitored in this view. Operating a telco cloud is costly, so optimal resource utilization is vital. Identifying the most and least used compute nodes by vCPU allocation, RAM allocation, or VM counts lets you determine if there's space to add or grow VNF workloads. One big challenge for telco cloud operators is to understand the dependencies between VNFs, VMs, and hosts. The GreySkies platform advanced mapping capabilities enable the automatic discovery of these dependencies and provides an intuitive visual representation of these relationships. This is vital for root cause localization. For instance, if a host machine faces performance challenges, we can swiftly identify the affected VMs, and crucially, the VNFs, thereby reducing service degradation. Ceph storage is an essential element of the telco cloud. Clear insight into read-write activities and OSD commit and apply latencies is vital for smooth operation. If the apply latency to an OSD surpasses a specific limit, it can impact the workloads and the OSD should be taken out of the cluster. The upcoming automation demo will showcase this scenario. We first define an event rule or can use anomaly detection to signal apply latency degradation. Then we define the actions that will take place specifically, send an email alert and run an automation workflow that will take the OSD out of the cluster. The GreySkies automation module is highly flexible and programmable to implement the workflow that is most suited to your organization. You can drag and drop boxes to design your own. In this case, once the event is triggered, it will prompt the ops team to approve the workflow and will send confirmation of success upon completion. So, let's run it. As you can see, there was a spike in the apply latency triggering the workflow. The ops team receives the email notification followed by an approval link along with the configuration change details. Once approved, the workflow will be executed. But first, the ops team will be prompted for confirmation, then another notification email will follow indicating success of the action. This can then be verified by navigating to the logs page to see that all stages of the workflow have executed successfully.
Okay, so Jim, I know we're tight on time. Is there time for two more slides, or?
Yeah, there's a nice use case here that you've got. Maybe, that demo provided a lot of information on sort of how different scenarios, but maybe you can talk a little bit about what you're actually doing in this one slide, and then we'll take some time for Q&A as well. Maybe this is a good case study, and then we'll have a really brief wrap up.
Sure. So we had a case study with a large mobile and fixed operator that had very highly competitive market dynamics, OPEX and CAPEX constraints, disruptions due to COVID and the globally challenging economic environment. And of course, elevated customer expectations. Everyone's expecting their mobile internet service or fixed internet service to be like it's a utility, like water, electricity, and so on. And they had this fragmented service assurance stack with multiple systems, expensive, and resulting in poor integrations between all these systems. And they were not able to really respond quickly or to customer complaints. And you know, what happens is a big incident happens in the network and everyone's running around trying to figure out what the issue is, exhausting for the team and not good from a customer experience perspective. We engaged with the operator and we focus on if you remember on the early slide 7, the first 3 blocks, which is network, service, and customer experience. And we collected data from everywhere in their network. We collected data from subscriber analytics data from the DPI gateway, from their packet gateways directly, which is an important discussion we can have some other time. Getting quality of experience metric, round trip times, packet loss, and we integrated with their charging nodes, the OCS node, to capture all the charging records and then correlate all this together. And the results of this were quite impressive, and we were able to consolidate on their service assurance budget and realize a 76% reduction on that. And we did that gradually. That did not happen overnight. That took about 18 to 24 months to get there. We're able to provide better visibility and have different teams within that operator, whether they're the quality team, the customer care team, the technology team, the operations team, to have view of the same, all through the multi-tenancy capability, have view of the same set of data. So everyone's talking the same language and everyone has are on the same, playing off of the same music sheet, essentially. One thing the CTO was very interested in is the smart CapEx strategy. We were able, because of the revenue insights that we're able to give and associate that with the customer transactions, you're able to tell, if I deployed capital at the site, how much exactly revenue did I get out of that? And so planning CapEx in terms of how to deploy it and the results, evaluating the results from that, from previous deployments was another big win for them. And then ultimately, we really partnered with that operator in their digital transformation by shifting, and this is where the future of service assurance, we believe, is going towards big data, analytics, ingesting information from everywhere, and treating it as such.
Great. Okay. So yeah. So let's just go to the wrap-up slide, and we'll have a little bit of time left. Well, not much time for Q&A, but I did want to just kind of give you kind of a wrap-up. Like, I think, you know, some of the things that we've talked about are some of the service assurance requirements is be able to have one pane of glass, be able to correlate all these different types of business customers and residential and network, support automation, learning. And the demo and all your slides talked about that, integrating with any OSS, BSS, and scalability, and then finally cloud native. I think those are some of the kind of the key messages in today's presentation. And we do want to get a couple of questions. I've got time, I think, for one question. But before we do, I just want to ask the audience, as the operator said at the beginning of the session, if you can, please complete the survey. That'll help us plan for future sessions as well. So maybe there's one question here really quickly, and I'll kind of get to it, and it's interesting. And I'll kind of paraphrase it. It basically talks about, you know, how do you help customers deal with redundancy? The note says the redundancy in the legacy world, it was kind of based on customer impact. It was, you know, there was redundant systems, but sometimes redundancy could have an impact on customer services. Whereas now with the whole new notion of redundancy, it's basically cloud-based, and the customers don't expect that even with redundancy that they will see any customer impact. Is that something that you've seen with your customers, kind of helping them go along this path?
Absolutely. So from a redundancy perspective, ultimately, it plays a role, obviously, from a resiliency and service delivery perspective. With things moving to the cloud, that sort of becomes, operators will not have to do what they used to do from an equipment on-prem perspective. They're relying on the cloud to perform that, whether it's geo redundancy, whether it is redundancy within the same location, they're pushing that requirement out to the cloud provider. And from that perspective, there's nothing for free. Ultimately, somebody's paying for it. Somebody has to manage that. But from a service assurance perspective, one of the things that we see from a redundancy perspective as well is that, sometimes when you need the redundant system, it's not there. So we should be able, one of the things from an assurance perspective is to your redundant systems, you need to make sure that they're up and running. And so through active probing, through test, you have to make sure they're always there, whether they're provided in the cloud or whether you're providing it internally. So testing the availability for these redundant services, you always have to do it. And we believe the service assurance platform has a key role in that as well.
Okay, unfortunately, we're gonna have to wrap it up there. So we're at the top of the hour. So excellent presentation, really interesting, and a lot of thought-provoking thoughts as well. It's really interesting to see how the evolution of service assurance is evolving. So I'd like to, again, thank you, Ahmed, for your presentation, and also to GreySkies for sponsoring today's session. I'd also like to thank the audience for attending today's session. And for Light Reading, this is Jim Hodges. We hope to see you again at future sessions. Thanks, everyone, for attending. We'll see you soon.
Thank you. Thank you.